Okay, so pretty easy lesson today, hopefully. But I've been doing this a while. Maybe not. We're talking about exponential functions. Because we've done natural log, we can now do exponential functions because they are related, and I know how much you love E. Okay, so we'll talk about natural log functions, talk about natural log exponential functions. We're going to integrate them, differentiate them, and then staying with the theme for this week. Anybody know who said that?
Jesus.
No. It's not Nelson Mandela, but that's a good guess.
Gandhi.
I say it all the time. It's not Gandhi, not Barack Obama. The Dalai Lama is correct. Winner, winner, chicken dinner. The Dalai Lama is trouble. He didn't cite the sources.
Especially when you put the two together.
Sell them up for the Dalai. T-shirt saying they got sold when he's done with his song gig, he's set out like also it's you die. No one ever has. If it's still outside, Alright, here is a graph of the exponential function. Bottom of that graph is the graph of the natural log function. We've seen that already, been working with that for a while. It is asymptotic to the y-axis. It passes through the point 1, 0. Strangely enough, if you take the inverse of the natural log function, you get an exponential function, e to the x. Since it is an inverse, it's reflected over the line y equals x, which means that instead of being asymptotic to the y-axis, it's now asymptotic to the x-axis. Instead of passing, excuse me, through the point 1, 0, it passes through the point 0, 1. It's an exponential function, grows very quickly, like the spread of zombies. Zombie bites one person, that person bites two people, those two people bite two people. Next thing you know, we've got a hit TV show. Again, inverses, we did that yesterday. You put e of x into the natural log of x, and you get x. You put natural log of x into e of x, you get x. Great for inverses. Awesome. Remember what that picture looks like. You should remember what that picture looks like, but we're going to use that as a reference for a lot of the stuff we're going to talk about. I can come back to it because all it takes is clicking, but we'll eventually talk about properties of that. But let's go to some pre-calc stuff. How do you solve that problem? Go again? Take the natural log of both sides. Go ahead and solve that bad boy. Without your calculators. What's the natural log of e to the anything?
Or all. The anything.
The anything, correct. Okay. So we should get that, take the natural log of both sides. The natural log of e to a power is just the power. You don't know what the natural log of 7 is, so you leave it alone. You get that, move the 1 to the other side, and everybody's good to go, right? If you prefer, you could do the natural log minus 1. I don't care. Any problems there? Outstanding. Ooh, if you're feeling saucy and you had a calculator, you could type it in and get a decimal equivalent. That's no problem. This is what I wanted to reference the picture. All the stuff about the curve. So you could read that, but if we go back to the picture, whoop, it's 1 to 1. Okay, passes the horizontal line does. It's increasing. Concave up or down? Concave up. What's the domain? All reals. What's the range? What is it? Could someone enunciate for me, please? Thanks for the help. Great job.
Yeah, I'm just going to be quiet. So the next time we really all I do is mumble. I'm good at mumbling, but I don't want to talk. Just didn't call on me because I'm not good at it from mumble.
Yes, Dawn? See, now if I were you, I would have answered in a mumble just to be a smart aleck. You missed a golden opportunity there, buddy. What is it? Are we including 0? No, because it's asymptotic to the x. Okay. I hate all of you. Okay, back to this. All right, yeah, we know that. Oh yeah, limits. If we go, if x is very small, negative infinity, it approaches 0. If you go to positive infinity, it goes to infinity. Keeps going up and up and up. More and more zombies. Okay. Good? Any problems? Awesome. What can we then do with e to the x? It's calculus.
Anything.
Well, okay, yes. Well said, Josh. We can do anything we want with it because this is calculus. More than likely, we would probably do 2 things with it. What would they be?
Differentiate and integrate.
Differentiate and integrate. What? Wow, what?
Nothing.
The big words?
Yeah.
Okay, excellent. All right. This, you may find this a little challenging. I apologize. Taking the derivative of e to the x is brutal.
Okay.
I'm being sarcastic. It's its own derivative. This is the weirdest thing in the world. You take the derivative of e to the x, you get e to the x.
Wow.
How is that possible? We're probably going to use number 2 more commonly because just taking the derivative of e to the x isn't very exciting. However, if you take e raised to some funky power, you got to remember to do an extra step. What is that du over dx, also known as?
Substitution.
No. Say again? A chain. Correct. Chain.
Spare chain.
Chain rule. Any problems? Good. What's a derivative of e to the 2x minus 1?
E. No, wait.
Oh,
2e to the 2x minus 1. Where, pray tell, did that 2 come from?
What?
Correct. The chain. The chain rule.
yes.
Right. What's e to the negative 3 over x? Oh.
Negative e to the negative.
I'm sorry?
Oh wait, so it's like negative 3 to the x, negative 3x to the negative 1. So that's just
Stay there.
3e, right?
What?
It's gonna be e to the 3e to the negative 3 over x. I don't know, man.
It's okay.
Itself.
times the derivative of that.
So 3. Wait, oh my god. What am I
No, because it's a negative already, and then it's.
My bad.
Paul, if you were the one kid who got 130 on a bio test.
I don't think I was.
130?
I don't think I was.
Yeah.
Any problems there?
Negative
Negative 3 over x is the same thing as negative 3 times x to the negative first power. Bring the power down. Reduce it by 1.
Yeah.
Negative times the negative is positive. You could have left it as 3 times x to the negative 2. However, we prefer to get rid of negative exponents. So therefore, that would go away. Okay, let's see how sharp you are. If the derivative of e to the x is itself e to the x, what would the integral of e to the x be? E to the x. E. Oh. Somebody brought their fancy pants today. Very good. E to the x plus c. Or more likely, e to the u plus c. Yes, you must still do a u du if u is not just x. Still need to do that substitution. Solve that.
No, to the other side.
Oh, sorry. That. Get it, she said go back. Now you good? No. Go get a big guy. Took the derivative of negative 3 over x. Whatever it is.
You got this, Jesus.
U to U.
Oh, that's right.
You got this.
You believe in me?
I do.
Whoa.
More than you can imagine. Probably more than you believe in yourself.
How do you not believe in Jesus?
You just call it Jesus?
Yeah.
He's done it before.
And what year ago today?
I don't know, Mr. Reedy. I'm stumped. I can't do it.
Well, to U to U, what would you try for U?
I don't know. Should we go with E? No. 3x plus 1? Sure. 3x plus 1. All right. Let's go for it. That's a plus. So, e to the u, du, right?
Not quite.
Not
You're
quite.
gonna take the derivative of U. No, don't erase.
Oh,
Take the
Yeah.
derivative of U.
oh yeah. It's just du
Coming back
equals.
to you now.
Oh man.
There you go.
Oh.
I'm not stopping.
Yeah. Golden.
Okay.
Watch out.
All right.
Coming into the home stretch.
And then got that e to the u. On the third, du, right? Let's go over there. And then
So close.
So is it?
It's its own integral.
It is. Okay, so 1/3 e 3x plus 1, right? Is that it?
Plus C.
Plus c?
Yep,
Oh, that's it?
that's it.
Oh.
You need your integral symbol in there until you actually take the integral. Good? All right, any problems? Similar to when we were doing derivatives of natural logs, I'm sorry, integrals of natural logs, it's not just always 1 over the thing, it's not always just itself, because notice if you just take itself, you'll miss that 1/3 term, which seems petty, but it's the right answer. Without it, you're 1/3 incorrect. So do you, blah, 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 blah. We are all done. Told you it was quick. There is an equation for it. I don't know what it is, but there is an equation that you could, if you wanted to plug it in, you could get that graphed on your calculator. Okay.
You know that.